My name is Tessa Rogers, and this is my data analysis and interpretation of the Measuring Matter science test that I gave my third grade students recently. The majority of my data analysis was done using a Google Sheet, which is also provided in this post, and I used portions of that data analysis to present to you here. My initial analysis led me to sort the scores of the entire third grade class into ranges so I may get a visual representation of the assessment of measuring matter. The data on this graph indicates that 20 of my 24 students, or 83%, scored at or above an 80 on the science test. While this is encouraging to see a large majority of my students achieve what I consider an on or above level of understanding on measuring matter, I still had 4 students, or 17%, score below level. Taking a deeper dive into the Class A and Class B averages, the maximum and minimum scores were identical, but the measures of central tendency as well as the score ranges differed. So the data indicates that in Class A, the majority of students, at 67%, scored above the class average of 90. There was an outlier in Class A with a student receiving 68. The minimum score by 12 percentage points. 11 out of 12 Class A students assessed demonstrated an understanding of measuring matter. In Class B, the data indicates that 9 out of 12 students scored above an 80. However, 3 out of 12 students scored below an 80 in Class B. The Class B scores indicate more variation, with 42% between 90 and 100, 33% between 80 and 89, 17% between 70 and 79, and 10% below a score of 70. I am inclined to interpret the variation of student scores in Class B as evidence of differing levels of conceptual knowledge of measuring matter. So just some more graphs here to compare the Class A score range and the Class B score range, which Class A scores indicate a higher level of understanding of measuring matter, and Class B scores appear to show a greater variation in their understanding of measuring matter. Then I wanted to take a deeper look into the questions and the levels of questions that I was asking my students. So the green color code on my Google Sheets indicates the knowledge level questions, and I looked at the third grade average score being at 90 with a standard deviation of 0.06. This indicates an adequate level of mastery of this curriculum content among the third grade students. The median and mode, both 88, appear to confirm a high level of proficiency and knowledge about measuring matter by the third grade students. However, when the knowledge level questions are broken down by classes, the data indicates different levels of achievement. Class A's mean score on these questions was 97, while Class B's mean score was 84. Class A's average of 97 and a smaller standard deviation indicates a high mastery of measuring matter at the knowledge level on Bloom's taxonomy. Class B's average of 84 with a greater standard deviation appears to show a lower level of mastery of measuring matter knowledge compared to the average of Class A. The mean scores for Class A and Class B show a 13-point difference in levels of knowledge on measuring matter. So examining the standard deviation of Class A and Class B indicates a distinction between the averages of questions 1 to 10. As the teacher, this appears to show causation for a more focused lesson to Class B on certain knowledge-based content in matter. Moving into the comprehension questions, which were indicated with a purple code on my Google Sheets, and they were questions 11 to 15. The mean score on the comprehension level questions was 91% with a standard deviation of 0.10. This indicates an adequate level of mastery of this curriculum content among the third grade students. When the comprehension level questions are broken down by classes, the data indicates a closer range of scores on questions 11 to 15. So Class A's mean score on these questions was 88, while Class B's mean score was 93. Class A's average of 88% and Class B's average of 93% presents a reversal of the knowledge level questions on the previous slide. Class B scored higher with a lower standard deviation than Class A. While the data was much closer in range, this appears to indicate a greater level of achievement by Class B students on this set of comprehension questions about measuring matter. As a teacher, I interpret this as Class B students were better able to articulate their thinking on questions 11 to 15 on the measuring matter test. In this case, both classes scored within 2 to 3 percentage points of the overall class average. This could indicate that classroom activities, labs, and textbook material helped third grade students comprehend measuring matter on level. Moving into these higher level questions, which I list as application, analysis, and synthesis, and on my Google Sheets, they are the orange color code. They're questions 16 to 18. The mean score on the application, analysis, synthesis questions was 78% with a standard deviation of 0.09. This indicates an approaching level of applying and analyzing this curriculum content among the third grade students. When these level questions are broken down by classes, the data indicates similar levels of achievement. Class A's mean score on these questions was 81%, while Class B's mean score was 82%. As indicated by the level on Bloom's taxonomy of questions 16 to 18, the data shows that these were more challenging questions with an overall mean score of 78% compared to the knowledge and comprehension questions with class averages of 91 and 90, respectively. Question 17 was of particular interest to me because measuring the volume of a solid was a focus of a lab and in-class discussion. So the question was, how can you measure the volume of a rock? And it was out of a possible 3 points. The mean score of 2.25 appears to show an approaching level of application on measuring the volume of a solid. It may benefit the majority of students to include measuring a solid's volume in the next lab to increase their level of mastery. Then I wanted to compare their scores against the diocesan grading scale. So as indicated on this table right here, we have a 97 to 100 as an outstanding grade. I have 4 students that fall into that range. Very good being a 90 to a 96. Good being an 85 to an 89. Satisfactory needs improvement, and then unsatisfactory. So according to the Diocese of Allentown grading scale, the data indicates that while the majority of my third grade students demonstrated a satisfactory to outstanding level of understanding of knowledge, comprehension, and application in measuring matter, 2 students did not meet at least a satisfactory level of achievement. So according to this grading scale, an unsatisfactory would not demonstrate a proficient level of understanding. This provides me with an opportunity to remediate measuring matter with these 2 students. It may also benefit the 7 students who scored satisfactory to review the science content on measuring matter as well. So overall, I had 92% of my third grade students score between a 75 and a 100. And I had 38% who earned a very good, and 8% of students scored below the 70. So according to the grading scale, that would equate to an unsatisfactory score and a possible failure. Thank you very much. Looking forward to your feedback.